Okay, this video will be basically talking about the classwork I've given you on Friday. I'm gonna explain how to solve enthalpy change using graph. Okay, so let's look at the example here. It's kind of similar to your book, but there's some differences, obviously. So let's get to it. As I said, these type of questions will be pretty long, so you have to underline or highlight the important information. Just be careful, because most of the time many of you oversee certain important information. So let's get to it. We have lead to bromide precipitate forms when lead to nitrate reacts with sodium bromide. So in this experiment we have 100 grams of 1.5 m sodium lead nitrate. So it is placed in a polystyrene cup. And the temperature of the solution was recorded every half minute for 2.5. Now this one, at precisely 3 minutes. We need this for the graph. 100 cm cube of 3m sodium bromide were added to the cup. And then that's it. So the graph was plotted here. So the first question, write an equation for the reaction between lead to nitrate and sodium bromide. So I'll just quickly write it over here. So even if you've forgotten what was the product, again, you can use your common sense since you've learned 2 years already. So we have lead to bromide, so Pb bracket NO3 solid plus sodium bromide. Sorry, this would be aqueous. Will form, so again, cation will react with the anion. So we got potassium bromide plus sodium nitrate. Now be careful. At the beginning, lead to bromide is given out. Precipitate. So the state should be solid. Okay? So you'll notice some questions give you all the hints you require, but you just have to understand which one is which. So this is solid. So as I said, if you got one of the states wrong, whole equation will be wrong. So next step, we have to balance the equation. We got 2 here. And oh, sorry, I forgot here 2. And then 2. Okay, so that's the balanced equation for question A. Next, find from the graph the maximum temperature rise of the mixture. So we have to use the method of extrapolation. Find the best straight line and then keep drawing. So we'll draw this one over here. Right here. Yep. So as many points as possible. Okay, next, at 3 minutes, right here, we have to draw the vertical line. So at 3 minutes right here, and then join back line of this one. So the minimum over here is, so the initial temperature is 27 degrees, whereas the final is, so each box represents 31, so each box represents 0.2. So 2, 4, 6, 8. So we got final temperature will be 31.8 degrees Celsius. So over here you just have to write 31. So the question B at the bottom is 31.8. So now we have all the information. We move on to question C. Now, assuming that specific heat capacity density is given the same thing, and find the enthalpy change of precipitation. Now, you'll be like, sir, we have not learned precipitation. Why are we even solving this? You will come across many different terms. Okay, so but you will notice this is using the concept of enthalpy change of neutralization. So precipitation is also exothermic. So, but since you don't have to know the definition for it, for the reaction mixture, the approach will be exactly the same. We have to find kJ per mole. So first thing, we have to find the energy required as well as the number of moles. So first off, let's find the energy required, the heat. So E equals to mc delta T. So what is the mass? So the mass, we have two things: 100 cm cube of lead nitrate, 100 cm cube of sodium bromide. So remember, we have to find the mass will be the end product, which means the total volume. So 100 plus 100, 200. Now notice that it's a cm cube. So as we know that it's 1 gram per cube, per cm cube. Okay, so next we just assume that it's 1. So 200 cm cube will become 200 grams. Specific heat capacity, it's given already, 4.18. Now delta T, the change in temperature. So maximum is 31.8, minimum is 27. Oops. So we got 31.8 minus 27. Okay, so after the calculation, your answer should be 4012.8 joule. Now in the textbook, what they like to do is to round off to 3 sig fig right here. As I said, you want to maintain accuracy, so you don't want to round off at this stage. So convert it into kJ, because we need the, so divided by 1000, so we got this. Alright, we're done with the energy. Next thing, we have to find mole. How do we find mole? Mole, we need to form the equation. So as we said, the equation is over here. Now I will write the ionic equation. It's the same thing. You can use this equation and write it here, but as I know that ionic equation is easier for me to represent, you can also choose to write this way. So we have Pb2 positive, aqueous, reacts with Br negative, aqueous, to form PbBr2, solid, 2. Alright, so now we ask ourselves what information is given. So over here, let's have a look for lead nitrate, 100 cm cube, 1.5 m. So 100 cm cube, 1.5 m, 100 cm cube, this one is 3 m. We have 3 m. So now what do you notice? We have 2 reactants. And then the mole ratio is 1 to 2. So what to do? The concept of limiting reactant might be used here. We don't know, so let's have a look. So find number of moles for both of them. So number of moles of Pb2 positive is equals to 100 over 1000 times 1.5. So again, we're using the equation. Molarity is equals to mole over volume. So mole equals to molarity times volume. And then we'll get 0.15 mole. So number of moles of Br negative, 100 again. Now this time molarity is 3. So we'll get 0.3 mole. Alright, now we have these 2 mole given, found. Next we have to ask ourselves which one is which. So we have Pb2 positive. Now this one can be done in rough work to find out which one is limiting or not. So at the end of the day, we are finding how many moles of lead bromide is formed. Okay, so our objective is to find this one. But now we have a problem. We have to choose which mole to use, Pb or Br. So let's have a look. Limiting reactant, we always use these 3 steps. We need, and then left. How much is left? So how much do we have? We have 0.15 mole of lead, 0.3 mole of bromide. So as I said,